Hello everyone. Today we are on day 2 of collecting like terms with exponents. But what we need to talk about today is what do we do when there are two variables? So maybe a problem has x's and y's, maybe the x's and y's are multiplied together, maybe they have exponents. What do we do? Well, we have two examples here in which these terms are actually in order in terms of the two variables. So let's talk about why these two problems are in order. So this first problem has A's and B's. If we think alphabetically, A comes before B. So it's kind of like A is in charge of this problem, so it gets to go first. These two terms here are the ones with the A terms. So if we look at just those two terms and we look at their exponents, this has an A squared and this doesn't have an exponent, so it's an A to the first power. So in terms of A, this is in order from largest to smallest. If we keep going, we have ones that are variables with just B's. So there's no more A's involved. Now we're just moving on to the next letter, B. And our exponents here are also in our order from largest to smallest. And then we end with the constant. Okay, let's look at our next example down here. So x's and y's, so alphabetically x is first. So which terms have x's? These first three have x's. And if we look at their exponents, it goes from largest to smallest. 3, 2, and a 1. Then the rest of the problem has just y's, and those are in order 2, then 1. So alphabetically, the variable that comes first in the alphabet is the one that comes first in the whole problem, and then the next variable is at the end. And your exponents have to go in order from largest to smallest. So let's practice just two problems, and we're going to do some combining of like terms. So our problem has 8r to the second plus 2t minus r to the second plus rt plus 8t plus t to the second. So alphabetically, what comes first in the alphabet? It would be R. So R is the one that's going to be at the beginning. It's the one that's like in charge. So we're going to collect all of the terms that have R's, and we're going to start with the one with the largest exponent. So my R terms, first of all, I just kind of say, where are they? They're there, and there. So those three terms have R's. The ones with the highest exponents are the R squareds. So those two have R squared. So 8R squareds minus an R squared gives us 7R squareds. Now this one with a plus RT, there is no other terms that have an R and a T. So we would just put plus RT. These terms here have just T's. So this is going to be the second half of our answer. So we have a highest exponent of a t squared. So that's this one right here. So I'm just going to add a plus t squared. Then we have a 2t and a 8t, and that gets us a 10t. So we have now written all of our pieces. Everything that has an R came first, and then everything that just has a t is second. Okay, so here's problem number 2. We have a 10x squared y squared. So notice that's one whole term. So it has x's and y's. They both have an exponent. Then we have a negative 9xy, a plus 7xy squared, a plus 3xy, and a minus 2xy squared. So we have x's and y's in all of our terms. Alphabetically, x comes first. And the term with the highest exponent on the x is this first one. And it's the only one of its kind. It's the only one that has x squared, y squared as the combination of its variables. So I'm going to write 10x squared, y squared, because that's our first term. Now, if we look at our next three terms, we look at the x's. Every single one of those has just an x. None of those x's have an exponent on it. But if we look further, they're not the same. This one has an xy, but this one has an xy squared. The next term has just a y, and the other term has an xy squared. So these two are matching and those two are matching. So the question is, which one do I write first? Because they both have just x's. Well, we look at the y's for the tiebreaker. So the y with the highest exponent is the one that's going to go first. So it's those two. So those two get to be combined and they get to go into the next part of our equation. So I have a 7xy squared minus 2 of the xy squareds. That's going to leave me with 5 of the xy squareds. Then if I look at my last three terms, because I just combined those ones, my last two terms, I have a negative 9 of the xy's plus 3 of the xy's, and I have negative 6 of the xy's. And that becomes our final answer. So be very careful when you're looking at your variables. Take your time, find those exponents, make sure the variables and their exponents and any combination of it exactly match before you combine them.